Welcome to the lecture on preheat and post-weld heat treatment for different materials. So, in this lecture we are going to have the discussion about the different methods of preheat and post-weld heat treatment, and especially preheating, and then we will also talk about some of the materials and specifically and how the preheating is done, what are the parameters which are set for the preheating of the materials. So, we studied about the necessity of preheating, and what we understood that once we do the preheating, then in that case your cooling rate which is experienced, it will be lesser than what it could have been otherwise. So, there will be avoidance of the hard surfaces formation, you have hard phases formation, and associated mechanical properties also are affected. So, if you talk about the different methods of preheating. So, as you know that you have the means like you may do the preheating with flame. So, then it is known as flame preheating. So, that is flame heating. Then you may do the heating with induction or resistance. So, in that case we call it as induction and or resistance heating. So, we can use the electrical means to do the heating. So, that way it will be induction or resistance heating. Then you can also go for the infrared heating, and we have another way to do the preheating, that is your quartz lamp heating. So, that way you have different ways to do the preheating. So, if you talk about the flame preheating, so if you go to the flame preheating, so in that case what we do is you have the oxy-fuel gas heating torches. So, we use the oxy-fuel gas heating torches. So, as you know that in this torch we have the oxy-fuel fuel is there. So, hydrocarbon fuels are there normally, and then you have the flow of oxygen also. So, you can have the control of various flame sizes, and you have the multi flame heating heads will be there in that torches, and you will have the use of smaller tips for the light heating, and you will have the larger tips for the heavy heating. So, that way you use the torches, and what we do is as we have understood that you have different types of flames that can be obtained by the combination of varying amount of oxygen to the fuel. So, as we know that you have three types of fuel, flames, that is oxidizing, neutral, and also the carburizing type of flame. So, that you have to adjust the amount of oxygen which is going inside the flame, inside that torch, so that you can get a particular type of flame in those cases. Now, when we use the multi-flame heating, so multi-flame heating heads, basically they are distributing these heat efficiency heat to a larger area. So, that way normally we use the adapter or the extension from the mixing chamber. Now, so as we discussed that you will have the control of the flow rate, you can have the proper selection of the hoses diameter, and you will have other fittings. So, that way you can use these torches to do the flame heating. Then flame heating heads normally are water cooled, and they have certain dimensions. So, that way this flame free heating is done. Another method is the electrical resistance heating. So, electrical resistance heating as compared to the flame heating will give you more flexibility. So, it gives more flexibility. So, flexibility in the sense that you can attain the temperature with more uniformity, and more quickly you can achieve the temperature, and wide ranges of temperature can be achieved using the electrical means. In the case of flame heating, many a times you will have because we do normally with the manual operators in that case, or you will have to adjust the areas in such a way that, and also for controlling there are certainly certain bottlenecks, whereas in this case you will have more accuracy and more flexibility towards getting this temperature and maintaining that uniformity also. So, basically we know we use that resistance principles for doing the heating purpose in all these cases. So, you can have the electrical resistance, you may have the concept of induction heating also, which is based on the electrical concept only. So, that way we do it. So, if you talk about the flame preheating and the electrical resistance preheating methods, now there are advantages and disadvantages also of these methods. So, if you talk about the flame preheating method, now its advantages is that if you talk about flame preheating, now in that case you have the low cost. So, this is for low cost and portability. So, these are the advantages of the flame preheating preheating if it is done with the flame, whereas there will be certain drawbacks. So, the disadvantage is in that case you have the minimal precision. And you have also repeatability. So, you cannot have the same repeatability, better repeatability in such case, because you do not have much of the control when we talk about the flames. So, repeatability will be the issue. Similarly, the temperature distribution in the case of flame preheating will not be uniform. So, you will have a non-uniform temperature distribution. And also in that case, as we discussed, that it will very much depend upon the skill of the operator, because he only will be better to do in controlling that flame, the type of flame which is required, suppose carbonizing or oxidizing or neutral. So, he will have the more he has to be more knowledgeable and more experienced to be able to get that particular type of flame in those cases. So, you require operator skill. So, this is another disadvantage in the case of flame preheating, or these are the challenges. If you talk about the electrical resistance heating, now in this case you have basically the more continuous and even heat that is formed. So, for electrical resistance heating, so in that case you have this is the advantage is that they are continuous and even heat can be maintained. So, you have continuous and even heat can be maintained throughout the operation. So, that is the throughout the operation of welding, as well as among the breaks also, during the break time also. So, you can have the break and then you can further start. So, that way you can have the continuous and even heat that it can be maintained. Another advantage will be that you can adjust the temperature very quickly. So, if you have to increase the temperature quickly, or if you have to decrease the temperature quickly, that can be done with very relatively ease. So, in those cases, so your temperature can be adjusted very quickly and accurately. So, in this case, in the case of electrical resistance heating, now they have not to, so the welders they basically they will be at relatively at more comfort, because mostly you have to have the many things work by pressing the buttons, suppose so that way the welders will be feeling more comfort in that, and they have not to stop things, because by controlling by using the machine itself, you can they can control the preheat temperature, they can increase or decrease it. So, and then another advantage with the electrical resistance heating is that if you want the differential heating, so basically uneven heat. So, if you have to put some heat more at some place and some less heat at other place, that can be done more easily. So, uneven heat can be easy, uneven heat can be obtained easily. So, so many a times what happens that in a certain part we require more and in other part we require less, or maybe especially if you talk about the take the example of pipes. So, if on the outer side, on the inner side you require different heats, so those can be maintained very more appropriately in the case of the use of electrical resistance heating methods. However, this electrical resistance heating method also has certain limitation, and the limitation is that there may be the element burnout. So, while working, so there may be element burnout during the preheating method. And then many a times when we talk about take the example of pipes, when we do, so in those cases there may be there may be short short may happen, and that may produce certain spot inside, and that may be the place of initiation of the crack. So, that that is another possibility of defect in the case of electrical resistance heating. Now, apart from this electrical resistance heating, we talked another heating another method of preheating, that was the induction method of preheating. So, what we do in the case of induction method, so we do the induction heating. So, in the case of induction heating, you can go for high heat, higher heating rates are possible when we use the induction heating, and so you have the high heating rates possible. And in this case you can control to a very narrow temperature range. So, temperature can be controlled in a narrow range. So, these are the advantages of the induction heating, and in that induction heating, those spots which are likely to be formed in the case of electrical resistance heating, that is basically not the case in the case of induction heating. However, induction heating also has certain limitations. So, if you talk about the limitations in that case, so the induction heating equipments require large setup cost. So, you have a high initial cost. And equipment is normally bulky. So, it is not portable. So, that is another challenge with the induction heating. And there are other challenges like you have for the non-uniform wall thickness and geometries, there are certainly some limitation. So, in those cases, and many a times if you have the need of extra coils, so you have extra setups required. So, certainly those points make it to somewhat discomfort to the welders or the person who is handling that. So, that is about the induction heating methods. The other method, which is that is your with the gas flame, which by an infrared heating. So, that way that is infrared, using the infrared means are the economical means of so using infrared. So, these are economical fuel, and in this case you do not require the insulation in the area to be heated. So, that way that is one advantage. And in this case you will have the only disadvantage is that you have to have separate furnace which is to be used. So, that is your use of the infrared heating equipment. And then also you have the other method is quartz lamp heating. So, this quartz lamp heating, so that gives basically very fast response time. So, these are the trait of this is that it is giving very fast response time. These furnaces, they have good efficiency, good cleanliness, and they are fast cooling down, and they have the quick turnaround. So, that is the advantage of this quartz lamp heating, but the disadvantage again is that you have high initial cost for high equipment cost is there for these equipments, and basically they are very fragile, these lamp so they are quartz lamps are very fragile. So, and also very much sensitive to the contamination. So, that way you will have to have the proper care for these processes. Now, we are going to have the discussion about the preheating temperatures for the different materials. So, if you talk about the materials specifically, the different materials will require the different preheating requirements, and it will be depending upon the material as composition as well as its thickness. So, based on that these preheating requirements will be varying, and if you talk about the steels, so you have different types of steels normally which we use for the welding applications. You have carbon steels, you have low alloy steels, you have stainless steels, many times we talk with aluminum or so. So, you have the different requirements, but if you talk about something like the carbon steels. So, if you see the preheating requirement for the carbon steels. So, now what happens that if your carbon is if your carbon is basically when you have low carbon steel. So, you have when you have low carbon steel where the carbon is less than or equal to 0.27% carbon. So, these steels they do not form the hard zones. So, these steels do not form hard zones. So, except in when you have in thick section with carbon with more than 0.20% carbon. So, except that it does not make the hard zones. So, so they are usually not very much hardenable enough to require any heating before welding, because otherwise when they are more hardenable, in that case you require to to do the preheating. So, so preheating basically. So, when you have these low carbon steels, in that case preheating is necessary only when you are doing the very heavy sections. So, preheating is necessary only when welding exceptionally heavy sections. So, this is for when we talk about the carbon steels where the carbon is more than 0.2% for heavy sections. So, in those cases we require the preheating, and the preheating temperature. So, so if you do the preheating temperature, if you look at the value, it will be varying from 100 to 200 degrees centigrade. So, this temperature will be varying from 100 to 200 degree temperature. But then there is another thing, that this temperature that should not be below the critical temperature for the transition from ductile to brittle. So, this temperature, that is preheat temperature, should not go below that, should not be below the critical temperature for ductile to brittle transition. For transition from ductile to brittle behavior. So, particularly this is important when we are doing the welding in the winter winter cases, or winter during the winter. So, we have to be careful for that, and because many times we are we have the danger of having the cracks. So, that is under the influence of these welding stress values. So, if the impact strength becomes small, so your notch impact values so if that is under the alarming level, so in that case it will be failing. So, so if the notch impact value goes below the value of 8 to 10 joule, so in that case there will be problem. Then preheating will be also necessary for when we are welding the carbon steel with very low carbon content, especially if you have a very thin plate which is welded to a very thicker plate. Now, if you talked about the thin plate, so you have to have the if you talk about the thin plate, so for corresponding to that you will have the smaller electrode diameter, and if the welding is carried out at room temperature, then cooling rate in the heavier plate, so that will that may be sufficiently rapid, and that will be hardening even the low carbon steel. So, that is so what we do is in those cases we do the slight preheating. So, we do the slight preheating of maybe about 50 to 100 degree centigrade for avoiding this hardening in those cases. Also what we do, another way to overcome this problem is that we do some we give some taper also to heavier section, so that you have the section of nearly equal thickness which is there. So, that also eliminates the risk of hardening. So, then if you talk about the medium carbon steel, so in the case of medium carbon steel the cooling rate, so for for medium carbon steel, when the steel will be carbon will be maybe from 0.27 to 0.45%. In that case the preheating requirement will be more. So, you will have 95 to even 370 degree centigrade of the temperature are required. So, in those cases, and if you go to the plain high carbon steels, so for plain high carbon steels, now this preheating requirement becomes more, because in these cases the hardenability is quite high. They are very difficult to weld because they can very easily form the martensite. So, and that will cause the brittleness. So, what happens that normally we have a control system of preheating, and in this case preheating temperature will be varying from 95 to 250 degrees C for the when the carbon is from 0.45 to say 0.6%, and you give maybe from 205 to 370 degrees C, this is 205, and you give from 205 to 370 degrees centigrade when the carbon content is more than 0.6%. So, this way the preheating requirement becomes more when you go to the to increase the carbon percentage in the carbon steels, and so that way when we if you talk about the multi run welds, in that case the first run will be heating the base metal. So, that way the heat of the next run will be basically tempering the base metal adjacent to the weld bead. So, then way in every run you will have the enough heat so that there is no rapid cooling, so that avoids the formation of hard zones. So, this is about the preheating requirements for the different alloys of different forms of carbon steels. And as far as the post weld heat treatment is concerned, so normally you have the stress relieving methods which are applied, and what you do in this case is what you do is you have to go for the stress relieving treatment. So, you are heating to a temperature which will be below A1, and then you are holding it for some time, and then further you are cooling. So, normally that is the process of stress relieving. So, this also varies from materials to materials, and normally what we do is, depending upon the alloy compositions, you have the different properties, like say what you do is you do the welding, and then you are coming and you further heating, and then you are holding for some time, and then further you are cooling. So, you do this process close to this A1 temperature, and then this way you will have the MF temperature here. So, normally that is the concept of stress relieving, that you are going to the temperature around A1, and then you are holding there for some time, and then further you are slowly cooling. So, that way the stress relieving treatment will be done. So, it is different for the different materials, and its main purpose is to relieve or to homogenize the structure, to relieve the material of the stresses. So, that is the main aim of the post weld heat treatment. Thank you very much.